Hey, welcome back. Today we're going to be talking about tectonic plates, forces between tectonic plates, and what stress is, and how do all of these things relate, and what are these things even. So this is meant for a physical science and a geology class. I do want to begin with this video here, and we take a look at mountains. Mountains are pretty amazing, and what forms them is pretty amazing. The geologic processes that can form them is pretty amazing as well. So we're going to take a look at another video, and I'm going to comment on it and talk through the concepts involved because the video is very good and has some great animations and images. So let's go ahead and get to it. Okay, and when we take a look at earthquakes and where they occur, it turns out that they happen, but not just randomly spread throughout the earth. They occur over very specific areas. These specific areas have a lot of stress associated with them, and we know now that this is where tectonic plates come together, either convergent or divergent plate boundaries, or transform plate boundaries as well. So let's talk in more detail about what the stress is, though, the stress. So first our video starts to talk about the difference between faults and plate boundaries, so let's talk about that before we get to stress. So at a small local level, you can get a fault. A fault is a point where two rocks will move past each other or break past each other. But on a bigger scale, we talk about plate boundaries. So you can have like hundreds of faults that interact at a plate boundary. Fundamentally, that's the difference between a fault and a plate boundary, is the sense of scale. Faults are smaller, plate boundaries are bigger scale. Okay, and so what is stress? Let's define stress. Stress is the tendency of an object to push back, to oppose an external force or external pressure so that it can maintain its original shape. So a force is measured in newtons, it's just a push or a pull. An area, we're talking about length times width. So a force applied over an area divided by that area is going to be equal to stress. We can measure this in pounds per square inch to begin to understand what this is about. If you have a 150-pound man over a 25-inch squared area, you end up with 6 psi, or pounds per square inch. Actually, that force divided by area that the man places is considered to be a pressure, and the pushback, the resistance to that pressure in the material itself is called stress. You can think of it as a responding force over a certain area, I should say, from the substance. Okay, and so I do want to say a couple things. This video that we're watching I believe is great, but this section on units and defining our terms needs a little bit of fleshing out. So let's go ahead and talk about it. First of all, I do believe that the pounds per square inch type of unit is actually pretty helpful for people to start thinking about this, because at least in the US we're used to pounds per square inch. If you've ever inflated a bike tire or even a car tire, that's measured in pounds per square inch. We use pounds for force as a unit of force. Although there are better units, the metric system is far superior to this. It uses base 10 and a prefix and root system that makes things very, very clear if you become comfortable with it. So because of that, I would say PSI. I'd say PSI is not a good unit to measure with because it's a non-metric system based unit. It's pounds per square inch. Now this isn't much better. This in parentheses over here that they're using kilograms per centimeter squared. The problem with this is that this is a unit of mass, so it leads to confusion. That's a unit of mass, not force. So what would I suggest that would be better to use? From a physics background, you could say pascals are much better. So you could say 1 pascal is equal to 1 newton per meter squared. I will write that out. Alright, so that would be a better unit to use for pressure, and stress is just the response to pressure. So let me explain what that means. So pressure is force divided by area, you could say. So it looks like pressure and stress are basically the same thing. They're not, although they're related and very similar to each other. So stress is the response to pressure. Let's think about what that means. If you applied compression, compression is a type of force that will push inwards from multiple directions. If you have compression over a unit area, over a certain area, you could say, then that is a pressure, and the response to that is stress. So the pushback, you could say, is stress? And why is there a pushback? Because of Newton's third law. So you could think of pressure as forces on the section of rock or earth that we're thinking about, and stress is going to be the response to that pressure. And a better unit to work with is going to be in pascals. So I just wanted to talk briefly about that as an insert to what we're looking at in terms of the video. Okay, and so let's talk about 3 different types of stress. This first type of stress is called extensional stress, then compressional stress, lastly shear stress. So let's talk about them. First, shear, working backwards. Shear has to do with forces that are shear forces, and shear forces work in opposite directions. Think of shears, another old-timey word for scissors. So shears have 2 blades that are moving in opposite directions, right? So shear stress is the rock or the material's response to these forces that are operating in opposite directions. Compressional forces and compressional stress are going to be similar. They're going to be pressing together on something, and so the stress is the pushback in terms of force divided by area. And extensional stress is the rock's response to tension forces. So pulling the rock apart in terms of the pressure will give a stress of extension. So that's what we're talking about here. Let's go ahead and move on. Okay, I do want to show credit and give respect to the original authors of the original video. You can see that information here. I will put information about their original video into the description for my commentary video here as well when I get a chance. If you have any questions or comments down below, please let me know. And I hope you all have a great day. Take care.